Good morning everyone. In this video, we will discuss about the structure of atom. Well, it is tiny but yet powerful. So here we will discuss, or we can say we will explore about how protons, neutrons and electrons are present inside the tiny building block of matter. So starting with it, we will start from the first subatomic particle, that will be electron. But really, was the first thing to be discussed called electron? It is not the point. So we will start from the Dalton's atomic theory. What was Dalton's atomic theory, which was proposed in the year 1808? The theory told that the atom is the tiniest particle which cannot be further subdivided. Lot of research and various theories were associated with it, but we got to the other end of the theory where we discovered a subatomic particle called as the electron. So what do we know about this? The electrons were discovered by a scientist called J.J. Thomson. He did an experiment which is considered as discharge tube experiment. Well, this experiment was something like passing electric current through gases in the discharge tube which were maintained at low pressure. Here you can take focus on what the discharge tube exactly looked like. It had a cathode, an anode, it had a space for the vacuum pump from where the excess pressure of the gas can be balanced, and we also had a battery which used to provide high voltage, or we can say a greater potential difference in the circuit. So how did we construct the discharge tube? Well, for that, we had a discharge tube which was made up of glass, and it consisted of two metal electrodes, like you can see the cathode which is negatively charged and the anode which is positively charged. And what were the conditions which we maintained in it? Were the low pressure and a very high voltage, and the vacuum pump was used to evacuate the pressure, we can say to reduce the amount of gas present inside the discharge tube, so that we can reduce the pressure present inside the glass chamber, also called as discharge tube. Now let's coming to the experiment. When the high potential difference were applied through the ends of the discharge tube, what we saw that a ray of light which was emitted from the cathode and traveled towards the anode. So it was something like a light greenish light which were having mechanical properties when they were passed from a perforated anode. So this picture can help you get an idea of the experiment where the voltage generator is being used to apply a high potential difference across the ends of the discharge tube. This one, from where the green light is being generated, is the cathode, and the other one which is perforated is the anode. Here we are seeing two things. First, the cathode rays are originating from the cathode and they are traveling towards the anode, whereas the perforations present on the anode help us to realize that the cathode ray also has mechanical abilities. That means it can be used to carry out some mechanical work. Now let us get in the detail of the cathode ray discharge tube. Here, first thing what we did, the current started flowing from the cathode to the anode and all the particles that were present inside it. So you can see as we turn on the circuit, the current started flowing from the cathode towards the anode. What happened in the second space? The flow of the current results in a ray called cathode rays. As we started this experiment, we found out that some rays were generated from the negatively charged terminal and they moved towards the positively charged terminal. And as a matter of fact, we cannot see cathode rays from our naked eyes. So how we could figure it out? We figured it out with the help of a zinc sulfide screen. It was placed on the end of the anode because the zinc sulfide is a phosphorescent material which glows when it's struck by a light particle or any other charged particles. So in this way we were to find out how a invisible ray which cannot be seen or located through the naked eye can be easily located with the help of a fluorescent screen containing zinc sulfide. What were the conclusion? What did we find out from this experiment? First, the cathode ray showed various properties, among which the most important one was that these rays are independent of the gases present in the tube. That means either you take hydrogen, helium, or any other gas, the properties of the cathode rays will remain as it is. The second point, they are not affected by the materials from which electrodes are made. You can make cathode or anode irrespective of any material, but the properties of the cathode rays will not change. Next is about their origination. As the name suggests, the cathode rays are generated from the cathode and they move towards the anode. Next is that if the cathode rays which are generally originating from the cathode, they often move in a straight line. But will it always happen that they move in a straight line? No. They only move in a straight line when the electric or magnetic field is not present. Next property what we have is they exhibit the behavior of a negatively charged particle. How we can say that? Because the cathode rays are generating from a negative terminal and they are being attracted towards the other terminal, which you can see over here is positively charged. So this cathode ray was ultimately named as electrons, and the same behavior, or we can say the same effect, was seen whether the in presence of an electric field or in presence of a magnetic field. And at last, how we got knowledge of this, that it is being produced as it is invisible to naked eye, is that it produced a glow when it struck a certain fluorescent material, which in this case was the zinc sulfide screen. Hope you enjoyed this little short video about the cathode rays. We will carry forward with such more videos in the future. Thank you.